The study of waves is really the study of energy being transferred from one place to another. In this video, we're going to focus on grouping that energy transfer into different categories, which we call a wave type. One category is electromagnetic waves. The other is mechanical. Let's see how these differ from one another. Electromagnetic waves, or sometimes called electromagnetic radiation, do not require matter to transfer energy from one place to another. They can transfer energy in completely empty space. The other category, mechanical waves, do require matter to transfer energy from one place to another. With mechanical waves, there's two types, transverse and longitudinal. A transverse wave is probably what you're familiar with of seeing up and down, because the energy transfer is happening, in this case, from right to left as the wave travels. And what is actually moving for a transverse wave? Going from left to right, the matter particles are actually going up and down. Matter particles are moving perpendicular to the direction of the energy that's being transmitted that creates this wave. Let's look at this more closely. We're going to look at what we call an equilibrium. This shows where the matter is when it's at rest, or its energy balance, where the average energy is for the matter that the wave is going to move through. At some point in time, the energy of the material at this particular point has been moved up here. And as time goes on, the energy cycles through this equilibrium position, meaning from its normal place, the matter that was right here has been moved up here. And the matter that was right here has gone here, and the matter that was right there, and the matter here hasn't moved. The matter here has been shifted to a position below its normal energy or resting position. Here it has not been shifted, and here at each of these particular points, an individual particle of matter has been shifted because of the energy travel through the material. Blue represents what the wave looks like a moment later in time. So the matter that only went this far now has gone this far from its rest position. And here, so from what was in rest position before, now has been shifted here. And this that was below the equilibrium position is now at the equilibrium position. So we have another transverse wave that looks something like this. If we use green to show the energy flowing through this matter even later in time, it's going to show a different shift, but following a pattern. So it would look apparently like that. Energy flowing through matter, examples like this are water waves, like a tsunami, and like a stadium wave that moves through the crowd where people stand up and then sit back down, transferring the energy. The other type of wave is a longitudinal wave. Sometimes this is known as a compression wave. For a longitudinal wave, matter moves in the same direction as energy. So here is some particles of matter. It's rather densely bunched. Here it's less densely bunched. And then again at another point in the cycle, the matter is densely bunched. Then it spreads out, later to become again densely bunched. Each dot represents a particle of matter, and where they're densely bunched together is equivalent to the peaks and the valleys you saw on the transverse wave. And energy transfer in a longitudinal way, or how earthquakes travel. Energy of sound is also a longitudinal wave. These are also known as compressional waves. There are two basic types of waves: electromagnetic, that does not require matter, and mechanical, that does require matter to transfer energy from one place to another. Mechanical waves may be transverse, where the particles of matter move perpendicular to the direction of the energy flow, and longitudinal waves, where the matter actually moves back and forth about a point as the energy flows in the same direction.